Hello, I'm Elena Berman, the Chief Science Officer for Kairos Aerospace. Thank you for joining me today as I tell you about our source-attributable quantitative results from a basin-wide airborne survey of methane emissions. But first, let's review the nature and scope of the problem. As you likely know, methane is a potent climate-warming gas, second only to carbon dioxide in its current effects on our planet. In fact, molecule for molecule, it is 20 to 100 times more powerful as a greenhouse gas, depending on the time frame used in the estimate. Recent reporting, both in the popular press and scientific journals, has highlighted the increasing urgency for reducing methane emissions. And herein lies a significant challenge. How do we find where the methane is coming from so that we can reduce emissions? And critically, how do we find the largest emissions? Because research shows that a small number of what are called super emitters are responsible for 50 to 80% of the methane emitted by the oil and gas industry. This is a huge challenge because oil and gas infrastructure is spread over a large geographical area. There's a lot of it, and it's far apart. So, an inspector with a standard handheld optical gas imager can cover about 2 to maybe 10 wells in a day. Keep in mind that companies typically have thousands of wells, not to mention all the gas gathering pipelines in between them. That makes this a really slow and inefficient process. This is where Kairos Aerospace comes in. Kairos uses infrared spectroscopy from small, lightweight sensor pods to detect larger methane plumes, such as those emanating from fugitive emissions from oil and gas infrastructure. Kairos sensor pods are deployed on light aircraft at general aviation altitudes and are able to inspect 100 to 150 square miles of infrastructure in a single day. On the left, you can see a photo of Kairos pod inspecting oil and gas operations, including, if you look closely, a lit flare. In the false color methane plume image you see on the right, white indicates high methane concentration, while blue indicates lower methane concentrations. You can see that the resolution of both the methane and the simultaneously collected optical images allow for precise, automated attribution of the methane emission with the asset, in this case, a tank battery. Kairos inspects all assets under the flight pattern, resulting in methane detections from a variety of infrastructure, as you can see here in examples from tanks, a compressor station, and known gathering lines. The simultaneously collected optical imagery not only aids in source attribution, but also serves as an additional inspection of the area. In this example, you can see that the methane spectrometer detected a gathering line leak, and the optical imagery detected liquids on the ground. On-site inspection by the pipeline operator revealed a damaged gathering line with a large liquid spray and pools beginning to form. In this specific case, the plants are still alive, indicating that we caught this early, avoiding worse environmental damage and more expensive remediation. Because we cover entire basins like this, we generate a lot of data, so we need an automated data processing system. After the data is collected, our automated system uploads the data to the cloud and orchestrates all of the spectral analysis, geolocation, visualization, and source attribution. Then our analysts take a look to verify detections and associations, and finally, reports are automatically created. At the completion of the automated analysis, we have a wealth of information about each methane plume that we have detected. This includes the time and date it was detected, the exact location of the plume, publicly available wind speed and direction from that time and location, the site from which the methane plume is emanating, and the size of the emission. Quantifying the rate of methane release is an important piece of information that we generate in addition to the detection and imaging of methane plumes. Because the Kairos technology images the entire plume, we are able to use a cross-sectional flux method without relying on complicated and imprecise Gaussian plume or other modeling techniques. Our process has been independently verified. In the fall of 2019, we completed a single-blind quantification validation experiment with Stanford University. On the right, You can see a figure from that preprint, which is currently under review and available on Earth Archive. It is clear that the scatter increases as the methane rate gets higher. In fact, the largest releases from this experiment were over 1,700 MCF per day, that's 1.7 million cubic feet per day, although of course these releases lasted just a few minutes. But the overall trend in the quantification is very good, with a slope of 1.15 and an R-squared of 0.84. Kairos is continuing to refine the quantification algorithms to improve upon these results. As I mentioned at the beginning, Kairos intentionally focuses on finding larger methane emissions quickly and inexpensively. Therefore, a very reasonable question is, what proportion of the total volume of methane released is observed by Kairos technology? Of course, we can't see what we can't see. In order to answer this question, we refer to a relatively recent report by the Environmental Defense Fund investigating New Mexico oil and gas methane emissions. Using on-the-ground surveys and bootstrapping of the data, the EDF has concluded that 80% of methane is released by just 3% of sites. Those sites are emitting above 41.6 MCF per day. On the right, you can see some more data from the single-blind validation with Stanford. It shows that Kairos detects essentially all of the leaks at that size. Therefore, we can conclude that Kairos detections represent approximately 80% of the total methane emissions from an inspected area. Practically, that result looks like this. Here you see an image of a section of the Permian with something on the order of 100 different sites, plus all the gathering lines between them. Where should we focus efforts on reducing methane emissions? These two sites. Something like 80% of the methane is coming from just these two sites. As I alluded to in the title, in 2019, Kairos completed a basin-wide survey of nearly the entire New Mexico Permian. On the right, you can see a map of all of the emission sources Kairos detected, with dots sized based on the methane emission rate. One interesting takeaway from this survey is that even though there are more than 30,000 active sites and more than 10,000 miles of pipeline in the New Mexico Permian, approximately 80% of the methane is coming from just over 1,000 sources. You can also see that a good number of the detections are quite large, with the 90th percentile of emission rates at 441,000 cubic feet per day. Based on this large-scale study, we have been able to gain new understanding of the sources of methane emissions. Again, we are reporting on the approximately 80% of methane that Kairos is able to detect, and based on this, we are able to generate some interesting conclusions. These include, although it is not common, simple well pads do leak, and these leaks do contribute a noticeable amount to the total methane emitted. If a flare is operating correctly, we won't see it. We only see malfunctioning flares. But when flares do malfunction, they emit a disproportionate amount of methane by volume. The most surprising result, perhaps, is that midstream operations contribute almost 45% of the total volume of methane, with 30% alone from gathering pipeline emissions. The data also allows grouping of emissions by operator. As you can see, there is a large variation in the average emission rate per well among the various operators, and it's not correlated with operator size. Small and large operators both span the ranges of emissions. For example, Chevron has invested heavily in eliminating methane emissions, and that is obvious by their detected methane emission rate. What I found surprising and incredibly hopeful in this data is this. Take a look at the performance of the top 20%. These low emission rates are clearly achievable since companies of all sizes are already doing that today. If all of the operators improved operations to achieve the same level as this top 20%, then the emissions detected by Kairos would be reduced dramatically by 91%. And the results are similar for midstream operators. If all operators achieved the performance of the best 20%, emissions detected by Kairos would be reduced by 81%. Taking into account that Kairos detects about 80% of all methane emissions, 60 to 70% reduction in total methane emissions could be achieved with all operators achieving the emissions of the top 20% across the board. And Kairos is working with our partners to do just that. So let's take a look at an example of the impact that basin-wide methane emission detection and repair can have. Kairos found 12 emissions from the assets of anonymized operator 333 out of a total of 257 inspected assets. These emissions put operator 333 near the top of the emission rate distribution. This operator can achieve a 45% reduction in methane emissions that Kairos can detect by fixing just the 2 largest emissions. Or they can achieve a 71% reduction in emissions by fixing the 4 largest emissions, an 89% reduction in emissions by fixing the 6 largest emissions, and a 95% reduction in emissions by going out and repairing just 8 sites. And they know which 8 sites will have this large impact because the methane emissions are quantified and attributed to a particular site. This analysis shows that repairing even a few targeted large emissions creates an outsized reduction in methane emissions. I hope that you can see from this data that large-scale methane surveys allow operators to make targeted, high-impact, and cost-effective methane emissions reductions. In 2019, Kairos data was used to stop over 3.9 billion cubic feet of methane from entering the atmosphere. That's the carbon dioxide equivalent of removing 425,000 cars from the road for the year. And for 2020, we are on track to nearly double that impact. So in summary, our data has shown that the methane released by oil and gas infrastructure can be minimized by utilizing aerial detection and quantification technology to rapidly detect large methane leaks over huge geographical areas, and that just a few small repairs can have a huge impact on global carbon budgets. If the rate of emissions per well for all operators were similar to that of the best 20%, that would create a 91% methane reduction from upstream and an 81% methane reduction from midstream oil and gas operators. And this is technology that works and is economically viable today. Today, together, we could reduce total methane emissions, that's all emissions, including the impact of both the large emissions that Kairos detects and the smaller emissions, by over 70%. Using Kairos data, our industry partners were able to prevent 3.9 billion cubic feet of methane releases in 2019, and already more than 3 billion cubic feet of methane releases in the first half of 2020. I appreciate your taking the time to listen to this presentation on the results from the Kairos Basin-wide New Mexico Permian Survey and the hopeful implications for the future application of large-scale aerial methane surveys for reducing greenhouse gas emissions from the oil and gas industry. Thank you.